Yes.
So in the last session, we have started the modeling of this truss in the ETABS software, and some part of the modeling we have completed in the last session. So this is our model. This is what our model, and how to do this, how to do the modeling of this truss we have seen in detail in last session. Some part I missed to cover before of the starting of the modeling. So when when you are going to create the model in your structure, so in ETABS software there are two types of elements. In ETABS software, there you will be able to find two types of element. One is your frame element, one will be your frame element, and another will be your shell element. Shell element. What does mean by this frame element? What will be included in this frame element? So there will be two your beam, your column, your spindle, your links. These all will consider in frame element. Okay, these all will be considered in your frame element, and shell element include your floor slabs, shear walls. These all are included in your shell element. Got it? So frame element is actually we are considering as line element, whose longitudinal dimension is very, very large in comparison of its other two dimensions. So if we are going to talk about the beam, so beam is having what very, kindly mute your mic is there, please. Okay. When beam is there, so beam is having suppose a 5 meter length, so depth is what 230, width is what, sorry, depth is what 450, width is what 230, so width is 230 only, depth is only 450. Try to understand. Our length is what 5000 mm. So length is very, very large in comparison of these two dimension. That's why we are going to call it as line element. So for all the line elements, software is considering as what? Frame element. So line elements are what? Your beam, your column. For the case of column, height of the column is very large, but cross-sectional size of your column or lateral dimension of your column, transverse dimension of your column is very less, 230 by maybe 600, or suppose height of the column is 3 meter, means 3000 mm. So length or height or depth of the column is very large in comparison of its cross-sectional dimension. Okay, that's why we are going to call it as frame element. And shell means your area element, means in plan two dimensions, that is suppose this x direction, this is suppose y direction. So along x direction, the size of the slab is suppose 7 meter, along y direction is suppose 5 meter, so 7 meter by 5 meter, and depth is what, suppose 120 mm. Thickness of the slab is what, 150 mm. So 7000 one dimension is there, another dimension is what, 5000. In comparison of its in plan two dimensions, the depth is very, very less. Depth is only 120 mm. Try to understand. 7000, 5000 and directly 120. So your depth is very, very small. That's why we are going to consider as a area element. So that's considered as a shell element in ETABS software. Understood? So whenever you are going to work in the ETABS software, especially for the RCC structure, like two elements will be there. One your frame element, another one your shell element. Frame elements means line element, and shell element is actually your area element. Understood or not?
Yes, sir.
Shall we proceed?
सर बीम कॉलम फ्रेम एलिमेंट में बीम कॉलम स्लैब क्या?
Beam, column,
नेक्स्ट
spindle. Hello.
Spindle and link.
Links. Okay. ठीक है, अभी इसके ऊपर आप फोकस मत करिए, ये थोड़ा एडवांस एलिमेंट्स हो जाते हैं. ये बीम एंड कॉलम अभी याद रखिए आप, ठीक है?
ओके
ओके. यहाँ पर इतनी चीजें, ये इंपॉर्टेंट एक पॉइंट था हमारा लास्ट सेशन का. फर्स्ट, देन काइंडली म्यूट योर माइक, इको विल बी देयर अदरवाइज. Okay. Now, after this types of modeling has been done, so these all are your frame element. That's why it is showing what? Frame. It is what? Showing frame. Got it? So this is all done. now we have to assign the load over your truss element or truss joints. Okay, we have seen in the last session as the assumption loadings will be only at the intersection point of two elements at the joint of the truss. Okay, the loading will be at that point only. At the ends of the elements or at the connecting points of the element, the loading will be only here. Just to show, actually the arrow is showing here, otherwise actually it is this loading is at exactly at this connecting point, intersecting point. So it is 3 kilonewton, it is 3 kilonewton, it is 2 kilonewton. So you know that what are the different types of the loading. So loading will be of three types. Basic three types are there. Point load may be there, line load may be there, and area load may be there. Point load will be your kilonewton, that might be known to you. Line load, kilonewton per running meter over the length of the beam, over the length of this length of the element. And area element means area loading is what? Kilonewton per meter square. If it is needed to assign the load over the slab, so that will be what? Area loading, kilonewton per meter square. If you need to assign the load over the beam, over the line element, over the frame element, so that will be uniformly distributed load. If you would like to assign the load to the particular joint, so that will be your point load. Or at any particular point of beam, if you would like to assign the point load, concentric load, that will be your point load. So that will be in kilonewton. So these are the three different types of the basic loading that we have to assign in the structure or in the project or in your model. But here our concern is to assign the loading to only loading. The type of loading is what? Point loading. And that point loading is what? That is over the joint we have to assign that load. Now close it. Come back to your ETABS. Now our model is basically ready. Okay, so here the loading we have to assign as how much intensity of the loading is there? 2 kilonewton. So this is what the assignment. If you want to do the modeling, so that you will that you have to do through the draw option. If you want to define something, if you want to set the list of something, you need to go to define. If you want to view something, what things should be in your view in front of you, so that will be in view. If you want to do any editing work, delete, adding, dividing, sorting, expanding, that all things editing work you have to do through the edit option. Okay, so this all assignment. If you want to do any assignment, you need to go to assign. If you want to analyze the structure, you need to go to assign. If you want to design the structure, you need to go to design. So many things are there. We will see everything in detail time by time. Okay, but here right now we have to assign the load over the joint. So go to assign, go to see all the three options has given in your ETABS software. Joint load. If you would like to assign the loading to a particular joint as a point load, so the joint load is there. If you want to assign the uniformly distributed load to the beam, okay, so that will be your frame load. If you want to assign the loading to your shell, that means your area. Okay, so you need to go to the shell loads. So all options are in front of you. So here our intention is to assign the load to the joints. So go to this joint, go to force. Once you go to this force, here load pattern name. I will talk about it in detail on later stage. What does mean by load pattern and name? Load pattern name. Right now, don't focus over that. Don't need to worry about that. आप लोगों को क्या करना है यहाँ पर? You just have to click over this live. Okay. अभी क्या है load pattern? What does mean by this load pattern? And what is the role of this load pattern? Okay. How this will affect on your modeling and means assignment of the loading. So that all things we will see on later stage. Right now, just remember that when you will practice, make it as what? Live. Is that all okay? Hello?
Yes, sir.
Yes, sir.
Okay. Now, thereafter, force in global X, force in global Y, force in global Z. So as I told you in the last session, ETABS software considering the axis, global axis system in this direction as X, in this direction as Y, and in vertical direction as what?
Z.
Very good. It is what? Z. Now close it. And coming back to our model, so as you can see, the loading in vertical direction, it is what? The elevation. We have seen that it is not the plan view, it is not the 3D view. Your truss is what? Elevation view. So elevation means it is in Z direction, vertical direction 2 kilonewton. But one thing you have to remember, this downward direction. Coming back to your ETABS, so I would like to assign in Z direction. So go to this Z, and I would like to assign the 2 kilonewton. Okay, now say simply apply. Try to understand this panel, how to use it. I will let you know. Very interesting it is. Apply. Nothing will happen. No selected object were found to receive this assignment. It is saying that what? There is no any object is in selection over which this load will be assigned. क्या कह रहा है कि आपका कोई एलिमेंट यहाँ पर सिलेक्शन में है ही नहीं जिसके ऊपर ये लोड असाइन होगा. हम लोगों को क्या करना है? हमें ज्वाइंट के ऊपर लोड असाइन करना है, सो दैट वी नीड टू मेक द सिलेक्शन फॉर दैट. जब तक कि आप सिलेक्शन नहीं करेंगे तो लोड कैसे असाइन होगा? सो अब मैंने सिलेक्शन किया हुआ है, one joint is selected. Okay, now I will like to go to this this dialog box, and now say simply apply. Now assignment has been done, but the problem is what? It is in upward direction. Our intention is what? Downward direction. So what thing I did wrong here? I have taken positive 2, so it is wrong. Then what? So here these three options are there. So make sure that replace existing load. So मैं क्या करूंगा? वापस से ये joint को select करूंगा. Replace existing load option here it is selected. तो जो भी यहाँ पर load assign है वो replace हो जाएगा new assignment के साथ. So मैं इसको क्या कर दूंगा? माइनस यहाँ पर put कर दूंगा, माइनस, and let's say apply. So ये upward replace हो जाएगा, remove हो जाएगा with minus sign से apply. Now it is downward. ठीक है? When your option is what? Replace existing load is checked. Now another option is there. Okay, suppose by mistake I have assigned the downward direction of 2 kilonewton load, but my intention to assign 5 kilonewton load in downward direction. So what I will do? अब कितना ऐड करना पड़ेगा मुझको 2 में 5 करने के लिए? To keep 5, how much value I have to add to these 2?
3.
Obviously 3. So अभी यहाँ पर मैं क्या करूँगा? 3 वैल्यू लूंगा, रिप्लेस एग्जिस्टिंग दूंगा, तो क्या हो जाएगा? पहले तो ज्वाइंट सिलेक्ट करना है आपको. फर्स्ट यू हैव टू सिलेक्ट योर ज्वाइंट, -3. If replace option is checked, what will happen? This load is going to be removed. This new load will be assigned. So that is your intention?
No.
Hello?
No, our intention is to make that 2 kilonewton to 5 kilonewton.
Very good. Our intention to make this 2 kilonewton to 5 kilonewton, convert to 5 kilonewton. So it should be what? Add to existing load. So पहले से 2 है, उसमें मैं और माइनस क्यों ले रहे हैं? Just for downward direction. For upward it will be positive. So -2 यहाँ पर already available है, उसमें -3 मैं और ऐड कर दूंगा. So ये आपका बन जाएगा -5, means downward direction. So here the option should be selected as add to existing load. Let's say simply apply. Now it is going to convert it to 5. So that is the case. I just want to share what is the application of these 3 options. And everywhere this option you will be able to see. In frame loading, in area loading. So we are trying to understand it here. Now suppose, okay, by mistake I have assigned the load to this joint. Actually there is, suppose no load is there. So now I feel that this load should be deleted. So what? I need to select this joint. I will go to this delete existing load, say apply. This is done. Understood or not?
Yes, sir.
Okay, so by default software will give you always replace existing load option. Check this option. Now drag it from left to right. मैंने selection का भी rule आपको कल discuss. Okay, drag it from left to right. Kindly mute your mic who is there, please. Okay, drag it from left to right. The joint is not selected. And now final loading is what, 2 kilonewton. Replace option is always by default will be checked, which is right. Let it to be, let's say apply -2. Come back to your question. Yeah, on left hand joint it is 3 kilonewton, on right hand joint it is 3 kilonewton. Actually, just to like it is actually at the joint. Okay, don't be confused. Okay, drag it from left to right, drag it from left to right. Okay, both of the joint I have selected in once, both of the joint I have selected in once. Close it. Again I am repeating the procedure. You have to select the joint, one joint is selected, drag it from left to right, another joint is selected. Then you need to go to assign, then you need to go to joint loads, then you need to go to force, and in this force what value will be there? Hello?
3
-3.
kilonewton.
3 -3. Let's say apply to this. Done. For both of the joint in once I have assigned, okay, as 3 kilonewton downward direction. This is all done. After that, let me check, is there any another load? No, there is no another load. It is what the reactions AX and AY, these all are the reaction value. Actually it is not there. Okay, this is not, we don't need to consider this. Okay, this is the results after the analysis. You might have done this kind of problem in your academics, in the engineering mechanics. Am I right or wrong?
Yes,
Yes,
sir.
sir.
Okay,
Yes,
very
sir.
good. Yes, good. Now coming back, okay. Now, after this, what next we have to do? Rest of all things has been done. Now, once your modeling gets completed, you have to check your model, whether your model is right or wrong. Whether your model is right or wrong, that we have to check. So, go to analyze, go to check model, and this joint check, frame check, shell check, these all checks you have to check carefully. I will discuss it all in detail on later stage. Right now you have to check all of this. Actually, what is this? We are going to check our model. Is there any modeling error? If it is there, then we will try to overcome that error. Okay, let's say simply okay. It takes some time and we'll give the notification whether, okay, pop-up will be there, model has been checked, no warning messages were generated. Means your model is perfect, there is no any error, any warning, so we can proceed for the analysis. We can proceed for the analysis. So just take it down. Now perform the analysis. Okay, so analyze. To check your model, you need to go to analyze, you need to go to check model, and the model will be checked. Now once your model is okay, you have to go to analyze and go to run analysis. Analysis means what? We are transferring the load that you have applied to your structure externally to the members of the structure. Wait for a minute. Hello.
Yes, sir.
Yes, am I
Yes,
audible?
sir. Yes, sir.
Shall we proceed?
Yes, sir.
Okay, good. Now see, kindly mute your mic. So after the assignment of the load and checking of your model, we have to proceed for the analysis. So go to analyze. Analysis means what? Like after the assignment of the load and after the completion of the modeling, assignment of the load, you have to proceed for the analysis. Analysis means what? For all the beginners, see, whatever the load that you have assigned to the structure externally, our intention is to transfer that load to the elements of the structure, elements of your model. So this 2 kilonewton load is going to be transferred to all these members. This 3 kilonewton load will all transfer into all the members, and that we are doing in our academic subject structural analysis. Whatever the load externally has given to your beam, we are finding how much shear force coming to this beam, how much bending moments coming to beam. So due to that particular load, how much stresses is going to be developed inside of your member, inside of your structural element, that we are actually finding out, and that is called as what? Your analysis. Okay, that is called as what? Analysis. So I am going to perform the analysis. So to initiate the analysis, what procedure is there? Go to analyze, you need to click on run analysis, one method. Second, if you are having this quick access bar, what does mean by this quick access bar? I will let you know later. So here also the option is what? Run analysis. So once you click what is the analysis, your analysis will start. Again, there is an option. If you are going to press F5 on your keyboard, so your analysis is going to begin. Okay, so any one of the method you can follow, but if you are beginner with this ETABS software, first time you are using, so go to analyze, then go to run analysis, and then click over that. So your analysis will start. So once you click over that, your analysis will start. It takes some time and will give you the analysis result. Here it is showing why warning. Okay, I will talk about it later. Okay, so now here we are having this, and see, just click over this start animation. Once you click over this start animation, so you are getting this kind of stop this kind of animation in your structure. It means what? Under the application of the loading, how your structure is going to be deformed, how your structure is going to be deformed, that you can see through this animated shape. But in actual, it will not. The deformation will be not like this. This is showing what? Over a large scale. This is showing over what? Large scale. This kind of response will not be there. But yeah, you can understand. Means from a long time we are here. We are knowing. We are understanding that your fixed support cannot move anywhere. Your hinge support cannot move anywhere. Your roller support is moving along the translational direction only. So this is the proof. Hello. Are you getting?
Yes, sir.
Your hinge support is having the restraint in translational direction, X, Y, and free about rotation. So here rotation will be the restraint against the rotation is there. Sorry, rotation is free. Here over the hinge support, rotation is free. And translational movement is what? Translational movement is what? Restrained. But for the roller support, only vertical translational movement is restrained. It can move in this direction or it can rotate about the axis. So there is no restraint against the translational movement in X direction or about movement. Okay, so that is what the proof. इसी वजह से आपका रोलर देखिए इस डायरेक्शन में मूव हो रहा है. बॉल इज द एग्जांपल ऑफ रोलर सपोर्ट. आप बॉल थ्रो करेंगे, so over the plane it can move in this direction, it can move in this direction, it can move in this direction, but it cannot move in downward direction. Why? Because there is a floor, and floor is what? The restraint in this direction. That restraint is there means what? There is a reaction. Hello, not getting?
Yes, sir.
Very basic I try to explain. Okay, so this is the proof. आपका ये रोलर सपोर्ट हॉरिजॉन्टल डायरेक्शन में मूव हो रहा है, बट नॉट इन वर्टिकल. तो ठीक है. Now thereafter, just go to this and clear this all. Close it. Now, so it is what? Animated shape of your structure under the application of loading. How your structure will deform. And see if I'm sorry. Hello. Hello. Okay.
Yes, sir.
Okay. Now I have to see how much forces coming in the member of truss. Member में आपके क्या forces आ रहे हैं, कितना tension आ रहा है, कितना compression आ रहा है, that I just want to see. So how I can see that? Go to this shape. Okay, sorry. Go to display. In common approach, I try to explain. Okay. Now in force stress diagram, in this option, then go to support reaction. What reactions are there? So go to support reaction. Now under which load we have assigned the under which pattern we have assigned the load, so that all patterns will be available here. We have assigned the load to the structure under the what? Live load pattern, right? Now I would like to see the result in arrow format, say arrow, and I would like to see the upward reaction, Z direction. Let's say apply, close it. How much reaction on this left hand? Left end 4 kilonewton. On the right end, it is what? 4 kilonewton. कितना हो जाता है आपका ये? Hello.
4 feet.
Is it right or wrong?
Right, sir.
Very good. Very good. Now, next, this is the reaction. Now, internal forces in the member of truss. So, go to display, go to force stress diagram, go to this frame pier spindle option. Again, go to display, go to force stress diagram, go to frame pier spindle, link forces, click over that. Here, under the live load pattern, what does mean by all these things? I will let you know after some time. But here my intention to see the actual, because member is what actually. So actual forces I want to see in the member. So we will focus to this. Okay. Now check this actual forces. Automatic. It is what scale. आपको कितना large देखना है, कितना small देखना है. That is what scaling. So it is not much important. आगे हम लोग इसके ऊपर भी देखेंगे, स्टडी करेंगे. Then display unit, display option. तो आपको इसको भी हम लोग मैं अभी आगे बताता हूँ. What does mean by this? Then it is what all these are frame element, area element, pier, spindle, link. What it is? Tell me fast. फ्रेम. सो फ्रेम ऑप्शन. अगर मैं पियर चेक करके ये ऑफ करूंगा तो कुछ भी आपको रिजल्ट नहीं मिलेगा, क्योंकि आपका फ्रेम है तो फ्रेम का ही रिजल्ट देखना है आपको. सो फ्रेम, लेट्स से अप्लाई, दिस इज डन. नाउ क्लोज इट. Now try to understand this result. Very interesting it is. Okay, this red color is showing compressive forces. Hello. This red color is showing compressive forces. This yellow color is showing the positive forces. Red color showing the compressive forces means your negative force it is. Yellow color means it is tension force, means it is the positive force. Yellow color is the positive force, means it is tension. Red color is means negative force, means it is what? Compression. Obviously the member is what? If it is this kind of force, so it is what? Compression. It is trying to compress the element. And tension means what? It is taking what? The loading like this, carrying the force like this. It is stretching. So it is tension, it is the compression. Negative force, it is what? Your positive force, right? So this is the case. Now go to this. Now go to clear this, all, close it. So this is what the positive and negative values. After that, yeah, I want to see in A and B, how much force is there? 6.928. Nature of the force or the sign of the force is what? Tensile. 6.928. Come back to your ETABS. Check, take your cursor here. How much it is?
5.192.
5.192. Coming back to your manual calculation result. So our manual, we have a trust on this manual calculation. So it is what? 6 point. Your result is showing what? 5 point. Okay. Come to BC, 3.46. BC, where it is? Yeah, 3.46. Come back to your ETABS. 3.48. Yeah, up to certain extent we can allow it. Okay, come to this. AG. Where is AG? AG 8 kilonewton. It is compression nature. So nature is right or wrong?
Right.
Nature is right. It is 6.4. 6.4594. Your calculation is what? 8. Tell me, will you accept this result or not?
No.
So,
Will you
Not accepted. Not accepted.
Why not accepted? Very close it is. Yes, Sushil.
It is close, but it's not so perfect as
Not
a
perfect.
manual.
So you will not allow it.
calculation. Yeah.
आप इसको एक्सेप्ट नहीं करेंगे मतलब?
नहीं,
थोड़ा तो फर्क है.
थोड़ा सा नहीं, काफी फर्क है ना. 6 की जगह पे 8 किलो न्यूटन यानी नियर अबाउट 2 किलो न्यूटन के आसपास में फर्क है मेंबर एजी में.
अच्छा, नहीं करेंगे एक्सेप्ट. ओके, ठीक है, आगे कभी चेक कर लेते हैं. ओके, नेक्स्ट G2F. G2F देखना है हम लोगों को. वेयर इट इज G2F? या GF is 5. ओके, कॉम्प्रेशन नेचर यहाँ पर नेचर तो 4.3 और इन एक्चुअल इट इज व्हाट 5. विल यू एक्सेप्ट दिस सुशील?
इसमें भी फर्क आ रहा है ना सर?
ये भी नहीं एक्सेप्ट करेंगे, देन फिर क्या कर सकते हैं? योर सॉफ्टवेयर इज रॉन्ग. ओके,
हेलो
यस,
हेलो सर.
हाँ बताएं.
सर मुझे ये पूछना था कि आपने कुछ अजम्पशन बताए थे शुरू में इसके ट्रसेस के. तो उसमें हमने कुछ अजम्पशन किए थे कि उसके सपोर्ट में जॉइंट्स पे मोमेंट हम 0 कंसिडर करते हैं, यानी मोमेंट ट्रांसफर नहीं होती है. तो वैसे हमने कोई मोमेंट रिलीज किए क्या सपोर्ट पे?
Yes, that is actually the point. Okay, Sushil.
Yes sir.
Now let's try to understand the algorithm. Actually, whenever you are going to model in ETABS software, suppose one element I am going to take here and another element I am going to model here.
One more thing, sir.
So this joint ETABS software is considering as rigid. What software is considering? Rigid joint. Rigid means it is having the fixity. It is having the fixity means this joint is going to carry the movement. अच्छा ठीक है, यहाँ पर डिफरेंस इंटरेस्टिंग पार्ट है. यू ऑल आर विथ मी?
यस सर.
ओके, अभी देखिए यहाँ पर रिजल्ट तो हम लोगों का डिफरेंस आ रहा है, बट रिजल्ट क्या है? सॉरी, रिजल्ट्स क्या है? ज्यादा मिल रहा है या कम मिल रहे हैं? तो हम लोग देखते हैं हम लोगों के मैनुअल रिजल्ट में. गो टू योर कैलकुलेशन A to B. Here your manual calculation is 6.9. A to B 6.9 and your software result is what? 5. कम मिल रहा है या ज्यादा मिल रहा है? हेलो,
कम मिल रहा है वो तो.
कम मिल रहा है. Okay. A to G it is 8 and your software is showing 6.49 something, 45 something. यहाँ भी कम मिल रहा है. Actually क्या है? Your software considering the joint, software what considering this joint where software is considering rigid होने की वजह से ये कुछ मूवमेंट कैरी कर लेता है. तो जो आप लोड डाल रहे हो उसका कुछ पार्ट एज अ मूवमेंट कन्वर्ट होकर आपका ज्वाइंट इसको कैरी कर ले रहा है. सो एज अ एक्चुअल फोर्स इट इज नॉट ट्रांसफरिंग टू द एलिमेंट. हेलो, दैट स्ट्रेस इज नॉट ट्रांसफरिंग टू द एलिमेंट. आपका ज्वाइंट उतना लोड बियर कर ले रहा है. राइट और रॉन्ग?
यस सर.
Okay, that's why ETABS software showing the less result and your manual calculation showing the little bit more result. That is what the right. In manual approach, we are considering this joint as a pinned connection. Pin connection means ये movement carry नहीं करेगा. जो आपने लोड डाला उसका एक्शियल बनाएगा और उसको एक्शियल बनाकर ट्रांसफर कर देगा. आपने कैलकुलेशन किया होगा, यहाँ पर एंगल बनता है साइन का एंगल बनाकर फिर वो लोड हम लोग ट्रांसफर करते थे. हैव यू रिमेंबर और नॉट?
यस सर, रिमेंबर.
Yeah, so this is whatever the total load you are going to apply, that total load is going to be transferred to these जितने भी एलिमेंट है उसको ट्रांसफर होते थे. But here it is what the software algorithm is what when you are going to model this joint were considered by the software as rigid और rigid होने की वजह से क्या करता है? मूवमेंट कैरी कर लेता है. बट हम लोगों ने assumption देखा था ट्रस का. We have seen that every intersecting point of the element is considered as a what? Pinned connection, or we can say hinged connection, or indirectly directly we can say that the joint is not carrying any movement. Understood or not?
Yes sir.
Okay, but that assumption we have not applied to our model, our structure. So that is the problem only, nothing else. Everything is correct. That's why our result is not matching. So now we have to edit we have to make these all joints as pinned connection or hinge connection, or in simple you can say that we have to make this joint free from carrying the movement. We have to release the movement from both of the end. तो उसके लिए क्या करना पड़ेगा? आपको एनालिसिस करने के बाद अगर आपको मॉडल में कुछ चेंजेस करना है, सो ऑब्वियसली आपके मॉडल को पहले अनलॉक करना होगा. जैसे ही आप एनालिसिस करते हो तो आपका मॉडल लॉक हो जाता है फॉर ऑल द बिगिनर्स. ओके, वंस यू कंप्लीट योर एनालिसिस योर मॉडल इज गोइंग टू बी लॉक्ड. आपको क्या करना पड़ेगा? फर्स्ट यू नीड टू अनलॉक योर मॉडल इफ यू वांट टू डू एनी एडिटिंग. ऑब्वियसली whatever, suppose मैंने 2 किलोन्यूटन यहाँ पर लोड अप्लाई किया था, उसके अकॉर्डिंग इसने एनालिसिस किया है. Whatever the load I have assigned to this joint, accordingly the load has been transferred. Now I want to change this 2 kilonewton to suppose 100 kilonewton. Obviously you need to like unlock, because 100 newton all the loading will be changed to the element. Okay, that's why every time if you want to edit the model, you need to unlock your model first. It is asking that, please note, unlocking of the model will delete all your results. Yeah, okay, I'm ready. Just say okay. Now model has been unlocked. Now clear this all, close it. After this, what our intention? Our intention is what? Okay, some of you may think that the loading has been removed. Here the loading is not showing. Loading is removed, right or wrong? Hello. Who is using this ETABS software or looking at this ETABS software?
Yes, sir.
Who is using this ETABS software first time? Fast, don't take much time.
Yes, sir.
Me.
Sushil.
Yes. This first time.
Yes, sir.
First time.
Me also, sir.
Saransh, first
Saransh.
time. Very good.
Yes, sir.
Very good. Okay. That's good. So I can understand how basic things I have to cover.
Yes, sir.
Okay, good. Now, see, you may think that the loading is now removed. It is not in view. So actually it is not the case. It is not in view only. The loading is there, not in view only. So if you want to keep in view, or if you want to make sure that what load has been assigned to structure at what points, so you need to go to display, go to load assigns, and what means we have assigned the load to the joint or to the frame. Obviously we have assigned the load to the joints, so you need to go to joint, and under which load pattern we have assigned the load, under the live, check this, and let's say apply, close it. Now it is in front of you. If I'm going to click over this undeformed shape, yeah, otherwise go to display and just go to undeformed, it will be what? Not in view. So it is not the meaning that it is deleted. Sushil, understood?
Yes, sir.
Very good. Now thereafter what we have to do? Yeah, we have to assign the releases to all the elements. So select all the elements like this, cut all the elements from right to left. Cut all the elements right to left. This is the one way. Another way, individually you can click over this each element. That is also the one way. Our intention is just to select all the members, nothing else. This is the way. So it is what? 11 frames are there, that all are selected. Now go to assign, and go to frame. These all elements are what? Sorry. These all elements are what? Frame. So assign. We have to we have to do the assignment to the frame. Go to frame. In frame, we have to release the movement carrying capacity of the joint. Go to release, and on the left and right of every element. So left and right. There is a brief and interesting discussion about movement 2-2 and movement 3-3 that will come later after this truss. When we are going to analyze the beam, there I will explain in detail about the movement 2 to movement 3-3. But right now, just check this 4 box. Let's say simply apply, and this is the sign that mention that we have assigned the releases. Okay, this is all done. Now undeformed shape, go to display, undeformed. Now it is not in view only. It is not the meaning the releases is deleted or removed. Okay, it is not in view. Sushil, understood?
Yes, sir.
Okay. Shraddha, Deepavali, Imran sir, Maya.
Yes, sir.
Good. Rishi. Pratik.
के जो अनडिफॉर्म
क्या?
ये जो
इको क्यों आ रहा? हेलो,
मोमेंट रिलीज किए तो उसको हाइड कैसे किया था?
सॉरी,
जो मोमेंट रिलीज करने के बाद में जो डॉट डॉट आए थे ना हर
हाँ हाँ,
जॉइंट पे एड पे, तो उसको हाइड कैसे किया
अच्छा,
था
ओके।
आपने?
सी, जो भी आपके मीन्स व्यूज में है, आपको नॉर्मल व्यू चाहिए मॉडल का, ओनली योर मॉडल एलिमेंट्स। सो आपको क्या करना है, डिस्प्ले में जाना है, अनडिफॉर्म शेप। ओके, यहाँ पर क्या है मैम? ओके, सी, असाइनमेंट हैज बीन डन। अब मुझको क्या करना है? ओके, फर्स्ट पहले दिखा देता हूँ। डिस्प्ले, लोड असाइन, जॉइंट लोड, live loads say applies. These loads are there. I have seen that this much loads has been actually is present over my model. So what now? I would like to hide these. Go to display and deform shape. Understood? Hello.
Yes, sir.
Okay.
यस सर, यस सर।
It is what very basic. Now, after release, now perform the analysis. Let the analysis to complete. Now this is what. Why this? I will let you know. See, this is what the 3D and animated shape. Go to elevation along the grid first. Say apply elevation view. It is what deform the shape. If I want to have normal view, so go to display and deform shape, not normal view. But the analysis has been done. Model is logged. Now I want to see the axial forces in the member. So go to display, go to force stress diagram, go to frame pair, live, axial force, and fill diagram, frame, say apply, close it. Now, see, come to this 6.9282. Go to this 6.928 tension. Then in this 3.4641, 3.460, very close. DC, okay, this will be same. AG is 8. Go to your ETABS. AG, exactly 8. Next to that, 5. Here, G2F is 5 compression. Now Sushil, now you will
Yes,
accept or not?
yes, it will be accepted.
Yeah. So
The
are you
results
getting the
are very
problem?
no, sir.
Okay. So this is the case how you can validate the results of ETABS software. So it is what axial forces in the member. So but here you need to remember for the axial forces, positive yellow will be color will be your yellow, means tension. A negative red color will be there, that is means what, compression. That is the case. Again go to display, go to this force state diagram, go to frame, and here user defined means scale. I would like to make it as 8, so it will large scale apply. Slightly scale is going to, image is going to be means zooming will be there, simple language. Fill diagram. Along with that, I would like to have the values. Check this. Let's say apply. So the values will also, it is showing 6.9, 5, 8, 3, 1.7 something. Okay. Now, if you like to have only the values, not the colors, say apply. Color will not be there. Are you getting? Hello.
Yes, sir.
So that is the case how to utilize this dialog box. Say, okay, this is done, now close it. Understood? Hello.
Yes, sir.
Now we'll move to the next example. Will you try this on your own? Hello.
Yes, sir.
Yeah, this is what the your homework. You have to do it. You have to practice it. Now I will discuss this one. Hello. You all are with me?
Yes, sir.
Yes, sir.
Okay. Now tell me, how many grids will be there in X direction, or how many grids will be in Z direction? Fast.
5
We
in
have to
X
move for this
direction.
example very fast. Okay.
5 grids in X direction.
5 grids in X.
Sorry.
5 grids in X direction.
US customary or metric SI?
Metric SI.
Metric SI, very good. You have to guide it. Guide for this model. Okay. Yes, tell me. How many grids in X direction?
5.
1, 2, 3, 4, 5. Very good. It is 5. How many levels will be there?
2 levels.
2 level. Okay. Now tell me, please. How many levels
4
are
levels,
there?
sir. 4 levels.
4 level. 1, 2, 3, 4. Very good. 4 levels are there. So additional level, how many? 1, 2, 3. ETABS software considering this as a base. So I am going to left it as base level. This is the first, second, and third. Additional 3, and this is the base. So total will become your 4. But we are considering it as 3. 1, 2, 3, and this is what base. So 3 levels will be there. Okay. Come to your ETABS. Number of grids in X direction 5. Number of grids in Y direction. Hello.
1.
1. Very good. 1. Ratio of grids in X direction.
5 meter and 6 meter last.
5 meter is typical, right? Repeating value 5. And in Y direction it will be 1. It is needed to go to custom or not?
Yes, sir.
Very
Yes,
good.
sir.
Very good. Just go to custom, go to edit grid data, and display grid data is spacing. Kindly mute your mic. Check this. Last one is going to become what? 6. Rest of all will be as it is. This is all done. Some dark color. So take okay. Now with all of this, just go to number of stories will be what? 3 additional. Now typical story height is what? That we need to check out. We will see bottom story height. Okay, come back to this. How you will come to know what is these heights? How much these heights? Hello. Yes. How we can calculate it?
Tan inverse 8 by 15.
Sorry.
Tan inverse 8 by 15.
Very good. This triangle we are going to consider to find out first angle. First we are going to find out the angle. Tan inverse of your height is 8 divided by your base. Base is what?
15.
15. It will be your 15. Give me answer.
28.0.
Sorry?
28.07.
Very good. 28.07 degree it is. Okay. Now, this is what the angle. Now, I just want to know this height. How I can calculate this? So it will become what? 5 times 10. 28.07. Right or wrong?
2.66.
Sorry?
2.66.
2.66. Is there anything up to third digits? Tell me.
666.
66. Okay, let it to be 2.666. Now, this height I need to know. This height. Now it is going to become 10 times 10, 28.10, 28.07. Check it how much it is.
5.332.
5 point. So first is 2.666 and second how much?
5.332.
Double three.
2.
2. Now third is directly your 8. Hello, right?
Ha. Third is 8.
8. Now take the difference of these two. Take the difference of these two.
2.666.
2.666 again you are getting, right?
Yes.
2.666. Difference of this 8 minus 5.332.
2.668.
Again 666. So these all heights are same, equal heights they are having, right? This height, and this height. Am I right or wrong? Hello?
Yes, sir.
2.666. Come back to your ETABS. So typical height will become what?
2.666.
2.666. Right, good. Bottom story. Again it is 2.666. Go if you are having any doubt, if you are having the confusion, so no need to worry about. Go to custom, go to edit story. Now you can correct from here. Base is your 0. First is 2.6. Second is also 2.66. 3 is also 3.66. 2.66. Cumulative height is going to become total height. Say 1 point. You can make it as okay 667. 66. Okay, 6667. Try with this 7. Now it is okay. Hello.
Yes, sir.
Okay, so now it is exactly 8. Now you can say cumulative height is total 8. Let's say okay, and we need to have the grid. Check this grid. Say okay with all of this. Now check, just short it. Go to elevation and go to this first. Let's say apply. Sorry. Go to elevation. Let's say apply. This is done. Is it visible or not?
Yes, sir.
Okay, good. Now come back to this. We have to start the modeling. So go to this frame, close it. This is the first point. This is the second point. This is the third point. I will have to take the help of the continuity. Click over this. Click over this. Now from here, I need to come to this point. Click over this. Unless until you are not getting the red sign or this grid point D1, it is what? It is showing that intersection. This is the label of this intersection. Is the base. Sorry. It is the okay, go to plan, come to any particular floor. So it is the B grid and 1 grid. If I'm taking my cursor here, grid point intersection of B and 1, right? Grid point intersection of C and 1. Hello.
Yes, sir.
So go to elevation first. Intersection point, it is what? 1 and C. At story 2. How clearly it is mentioning everything. C and 1 at story first.
One.
Understood or not?
Yes, sir.
So unless and until this definition you are getting, you don't need to click over that. Okay. So I'm getting this. Now I'm going to click over this. Okay. Or you can start from here. Click this first point. Coming to this. This is done. Now I'm taking the see why it is assigning the support here. Can anyone?
It's also automatically assigned.
Automatic.
Why?
There is a baseline.
Sorry.
Because it's the base.
Yes, because it is at the base. That's why it is assigning. Yesterday I have explained this point. Very good. Kindly meet. Yes, click over this. Now modeling has been done. Right click over that. Okay. What next? Yeah. From here to here, we are having the point. Click over that. Right click. From here to here, right click over that. Then right click to off the continuity. Coming back. Now from here to C, from G to D. From here to C, right click. From here to G, right click. This is done. And now here also the element is there. This is also done. Okay. Now go to this. After that, drag it from left. Okay. After that, what all the elements has been modeled. All the elements has been modeled. Your grids are very dark. So go to edit, go to edit history and grid system. Go to modify. Color should be make it to light. Say okay, okay, okay. Now, hello.
Yes,
Hello.
sir.
Hello.
Yes, sir.
Now, if you would like to off these grids, if you like to off this grid, right click and set grid system visibility. Once you click over this, your grid will be off. Hello.
Yes, sir.
When you, if you would like to have your grid in front of you, right click, set grid system visibility, click over that again, it will be enabled, it will be in view. Again click off, on, like that. Okay, so your choice. If it is not needed to have this grid, you can make it to be off. Now, after the completion of this walk, here the support is what? Roller support. So drag it from left to right, select the joint. So how many joints in selection? 1. And then go to assign, go to join, go to restrain, and it will be your none. Sorry, it will be your roller, and let's simply apply. The roller suppose has been assigned. Drag it from left to right, and it is what? Hinge support. Select this hinge and say apply. This is also done. Okay. After the completion of the modeling, what we need to do? We need to check our model. मॉडल कंप्लीट होने के बाद आपको क्या करना है? मॉडल को चेक करना है whether is there any modeling error or not. Hello. Go to analyze, check model, select all of these, and let's say simply okay. Let's check your model is right or wrong. Is there any problem in your model or not? No, there's no modeling error. Close it. After that, we have to assign the load. Tell me how much the loading is there. 24 Newton. Here it is 40 Newton. So Newton, how much it will be in kilonewton?
2.4. Sorry, 24. 21.
Yes.
0.024.
0.02.
0.024. 10 raised to minus 3 divided by 20. Divide this 24 divided by 1000. Very simple it is. 0.024. Right or wrong?
Right, sir.
40 divided by 1000. That is going to become 0.04. Close it. Go back to your ETABS. Select this joint. Go to assign. Go to joint load. Go to restrain. Sorry. Go to assign. Go to joint load. Go to force. It is under the live load pattern. It is minus 0.24. Okay. Sorry. 0.024. Say apply. This is done. Drag it from left to right. Joint is selected. It is what? 0.04. Let's say apply. This is also done. Okay. All the load has been assigned. It is what? 0.024 is there. But it is showing up to the 2 digits only, 2 decimals only. Hello, Imran sir.
Yes, sir. Yes, sir.
Yes, sir.
Yeah. After that, what next? Let me check. Yeah, this is all done. We can proceed for the analysis. Now go to analyze and just click over this run analysis. Let the analysis, it is first asking to save your model. So I will have to save this model by the name as 6. Save this.
Moments.
Let the analysis to complete. Okay. Okay. After this, go to this 3D view. Sorry. Go to start animation. your model is having, or your model is not having any this is what deform the shape of your structure. Okay, under the application of loading, if you are taking your cursor to any point, so what value you are getting? What you are getting? Okay, tell me.
Displacement.
Okay, for the 3D model, each joint will have how many degree of freedoms?
3 degrees.
Three degree of freedom.
Very good. Anyone else? Sushil. Imran sir. Saransh. Deepavali. Shraddha. Rishi. Shahnawaz sir. Saurabh. Hello. Are you there or not?
Yes, sir.
Yes,
Then answer to me. Take the attempts. Pratik.
Yes, sir.
How many degree of freedoms for the 3D model joints?
3 degree of freedom, sir.
3 degree of freedom. Who said
2 degree.
2 degree? Okay. Deepavali.
It will be 6 degree.
Who said 6?
Sushil.
Sushil. Okay. Saransh.
Yes, sir.
What do you think?
The 3 degree of freedom.
3 degree freedom. Okay. Who said? Actually, your model is having 6 degree of freedom. How many? 6 degree of freedom. Try to understand the concept. When you are taking your cursor to any joint, okay, so it is okay, any point, forget about that all, any joint, what possibilities are there? This joint can move in this direction. That is, I'm going to call it as translational movement, horizontal movement, not movement, it is movement. Okay, displacement. So translational movement in x direction, translational movement in y direction, uy. This joint can move up and down. So it is what? Up. Translational movement in z direction. Rotational movement about x direction. Rotational movement about y direction. Rotational movement about z direction. Now tell me how many degree of freedom will be?
6.
6.
Degree of freedom.
Good. So this you have to remember. Each joint of 3D model will have the 6 degree of freedoms. So when you are taking your cursor to any joint, it will show the result. How much translational movement in X, Y, Z, how much rotational movements are. So that all things you can find from here. Just for your knowledge, for your information, I have shared this point. Okay. Now next. So I would like to have make it as undeformed shape. Go to display, undeformed shape, normal view, lane. Then we have to see the forces. Go to display, go to force stress diagram, go reaction. You can also see under the live load pattern. We have assigned the load and arrow format in Z direction only apply. It is 0.08, 0.02. Go back, see. Yeah, reaction is not showing. So okay. Go to display, go to force stress diagram, go to frame peer, and under the axial force, automatic field diagram frame say apply, close it. Check it, how much reactions? 0.0. Okay, go to display, go to force diagram frame and make it as what? Show values also, apply, close it. 0.0247. 0.0274. Go back to your calculation. A to B, B to C, C to D, D to E. For all, the loading is reaction is what? Tension nature 0.03. Hello, right?
Yes, sir.
0.03. It is 0.0271, 0.0281, 0.0299, 0.0296. Is it right or wrong? Wrong.
It's a nearly
Hello.
close.
Wrong, sir.
इसमें मोमेंट भी तो रिलीज करनी पड़ेगी ना सर?
मोमेंट रिलीज नहीं किया
हम
सर,
लोगों ने किया नहीं मूवमेंट रिलीज, राइट?
मोमेंट रिलीज नहीं किया
हाँ।
सर।
हाँ, अभी एक प्रॉब्लम और है। क्या प्रॉब्लम है वो?
यूनिट
बताएंगे आप क्या प्रॉब्लम है? आपका ये एलिमेंट हम लोगों ने कंटिन्यूअस मॉडल कर दिए। देखिए आप,
हाँ
एक्चुअली क्या है, हम लोगों ने क्या अभी लर्न किया था, हर ज्वाइंट पे आपका एलिमेंट ब्रेक होता है, ट्रस्ट का एनालिसिस अजम्पशन है। हेलो,
यस सर।
सो ये भी
Yes,
हमारा
sir.
मॉडलिंग रॉन्ग है, प्लस हम लोगों ने रिलीज भी नहीं असाइन किया है। बोथ द थिंग्स आर रॉन्ग, सो वी नीड टू चेंज द मॉडल। फॉर दैट आई नीड टू अनलॉक माय मॉडल फर्स्ट से। ओके, अभी पहले देखते हैं हम लोग इसको ब्रेक करना है। सो ये ज्वाइंट को लेता हूं, ये फ्रेम को ब्रेक करना है। सो सिलेक्ट द फ्रेम फर्स्ट, देन सिलेक्ट द ज्वाइंट, both of the joint and frame, then go to editor, edit frame, divide frame, break at intersection. Let's say apply with this, say apply. This is done. Now this is the separate, this is separate, this is separate. Understood? Hello.
यस सर।
Yes.
Now perform the analysis. Okay, select the all elements. I am going to cut all the bars, all the elements. Now go to assign, go to frame, go to releases and partial fixity, left right say apply. This is done. Now go to perform analysis. Let the analysis to complete. Start animation. Okay, this is right. Now go to display, post stage diagram, frame pair spindle. Let's say apply with all this. Now 0.03, 0.03, 0.03, 0.03 exactly. Here all this 0.034, 0.034, 0.0 means 34. 34. It is what? 50. Okay. 34, 50, 24. 24. Here it is 0, it is 0, it is 0, it is 0. 100% correct or not?
करेक्ट।
Okay, so in this way you have to validate the result for the actual forces of the member. Okay, so इसमें hope that you might have learned a lot of important things with this thing. Okay, with this truss element only. Now move to the next. We have to look at the beam. We have to look at the beam. How to model this beam? So tell me, what are the different types of the beams? Hello.
cantilever beam, simply supported fixed beam.
Cantilever beam is there, simply supported beam is there, and what
Continuous
else?
beam.
Sorry,
Fixed beams. Supports
fixed
are
beam is
fixed.
there. What else? What else is there?
Singly reinforced beam, doubly reinforced beams.
that is depends on your presence of reinforcement. I'm just asking about based on your support condition.
Proper cantilever.
Yeah, proper cantilever is a cantilever, simply supported, continuous, fixed beam. Okay, based on support condition, there are so many different types of the beams. And the main concern for the design of the beam is your shear force diagram, bending moment diagram. Shear stresses and bending stresses that you have to find in your element, in your member. Actually, we have to model this beam, and we have to see how much stress is coming to this member. But before of that, we need to understand some important things. Okay, so as I told you, your beam is the frame element. That means we are going to consider is a line element. Okay, so in the last session we have seen that each element will have its own axis system. Deepali, are you there? Maya, are you there? Hello.
Yes,
Maya,
sir.
are you there? Hello.
Yes, sir. Yes, sir.
Okay. Now, two axis systems are mainly, actually three is there, but most important is two. One is your global axis system, another one is what? Local axis system. Okay, global and local. So global axis system where software is showing by X, Y, and over height Z. But when you come to see at local axis means the member axis. So it is in X direction or not in X, along the longitudinal direction of the element. Longitudinal means along the longer side, longer span of the element. So beam is having along the longitudinal direction. So it is what software is considering as 1-1. Right or wrong?
Yes, sir.
Yes, sir.
Along with
Yes, sir.
software considering this as 2-2, and along the height or depth it is considering as along the height and depth it is considering 2-2, and along the third direction it is considering as 3-3. So local axis is representing by the numbering, global axis is representing by the XYZ. That is what the difference you need to mention it, you need to consider it. Another, okay, after that, it might be in your knowledge, there are three equilibrium equations. What are those? Summation f of x,
Is
summation f
equals
of
to
y,
zero.
summation f of, right? Z
Moment.
about the third axis. So summation f of z is also the third axis 0, or we are considering about third axis movement. Hello.
Yes,
Yes.
sir.
These are the three
Yes, sir.
equilibrium
Yes, sir.
equation, third axis. So in your beam is what? Flexural element will be subjected to transverse loading only. Your beam is subjected to transverse load only, and there is a presence of support to this bottom side. So transverse load means in this direction. Here the loading is, and your support is actually present here. Okay, so there is no like question that your beam will be subjected to the loading along its longitudinal axis. There's no case the load will come along this direction, right or wrong?
Yes,
Right,
sir.
sir.
So your beam element is not carrying any axial force. First thing, okay. So for the beam case, we don't need to look at the axial force. Now, these two directions remaining 2-2 and 3-3. Try to very important point. No one will tell you about these all things in detail. I am trying to explain very important thing. Try to understand. Now, along the depth. So if I am going to take a beam like this, which is resting over a support, and this beam is supposed subjected to any transverse loading. So under this application of the loading, your beam is subjected to what? Your beam is subjected to shear force, and shear force will be what? Shear force diagram, if suppose beam is subjected to uniformly distributed load. So shear force diagram will be what? Like this. Right or wrong?
Right.
Yes, sir.
If the only axial load is there at the center, shear force diagram will be like this. Right or wrong?
Yes, sir.
Okay, it means that over the support, your shear force is very, very large. Due to this very large intensity of the shear force, there will be the possibility of development of the shear cracks in this direction.
Yes, sir.
So shear, what I would like to discuss that your shear force is developing over the depth of your member. Hello.
Yes.
So your depth axis 2-2 is there. Hello.
Yes.
Okay, so that's why whenever you are going to your intention to look at how much shear force is coming to your beam, you need to look at the axis
2
2 2. So this is called as major axis for shear. Major axis for shear is 2 2. Minor axis for shear is what?
3 3.
3 3. And the third axis that is out of the plane we are going to consider. About that there is a possibility of the movement. That is the third axis for the movement. That is what? Axis. Hello. 3 3. So major axis for movement is what?
3 3.
And major axis for shear is what?
2 2.
2 2. Minor axis for shear is what? Shear is what? 3 3. And minor axis for shear movement is what?
2 2.
2 2. Reverse it will be there. So okay, you don't need to remember minor. You have to remember only major. So if I am telling you, let me know how much shear force in the beam. So what you will in which axis you will look at the shear force?
2 2.
2 2. If I am asking how much movement in the beam, what you will look for?
3 3.
Sorry?
3 3.
3 3.
3 3.
Axis 3 3. Understood or not?
Yes, sir.
Yeah. But it is not the meaning that there will be no shear along the 3 3. Some shear will be there that will be negligible. That's why we are going to call it as minor shear axis. And it is not the meaning that there will be no movement along the 2 2. Movement will be there along 2 2, but that will be very minor that we can neglect. So that's why we are going to call it minor axis for the movement 2 2. Minor axis for the shear is 3 3. Okay. So actually you have to remember very simple. Major axis for shear force is 2 2, and major axis for your movement is what?
3 3.
3 3. Is that all clear or not, Imran sir?
Yes, sir.
Yes, sir.
Yes,
Okay.
yes, sir.
Go to clear this all. Now close it. Go to this example. So you all said that it is a cantilever beam. You all are right. But one more thing I would like to know. It is elevation view, plan view, 3D view. What kind of view it is?
Elevation.
Very good. It is the elevation view. One beam is there, or it is a different beams are there. One beam is there. Okay.
One beam.
Yes. Come back to your ETABS. Okay. Tell me how many grids will be there in X direction?
4.
We are
Four
considering
number of
this
grids.
model.
Four number of
in,
grids.
yes, in XZ plane. In XZ plane. Okay. So X direction, 4 grids. You all are right. I am going to take a go to file, go to new model, say no this, go to metric SI. Sorry, go to this third option. Metric SI is all. Let's say simply okay. With all of this, you said that we have to take 4 grids in X direction. You all are correct. 4 in Y direction. How many?
1.
1. Very good. 1. Spacing of grid in X direction. Tell me fast. It is different, right?
Different.
Yeah. We need to go to custom. Make it as 1. Go to custom. Go to edit grid data. Go with this option. So now, first spacing is 0.5.
5.
0.7.
0.7, 0.8. 0.7.
No,
Sorry.
sir. B is 0.7.
Yeah. 0.7.
0.8.
Very good. 0.8. Now, with all of this, make the bubble small. Okay. Rest of all things as it is. Let's say okay. And it is not the matter of the level, but we are going to make it as all 1, 1, 1. Okay. And go to grids. Let's say okay. This is done. Now close this 3D view. Go to elevation along the grid first. Say apply. Close it. It is the elevation. Base is also there. First level is also there. So your choice on which level you would like to walk. Tell me.
Story 1.
Story 1.
स्टोरी वन बेस पर करेंगे तो ऑटोमेटिकली आपको बार बार सपोर्ट असाइन कर देगा वो, राइट और रॉन्ग?
राइट सर।
Yes.
वेरी गुड।
Sir.
क्या करेंगे हम लोग? फर्स्ट लेवल पर काम करेंगे। नाउ कम टू योर फर्स्ट लेवल। ओके, कमिंग बैक, दिस इज द फर्स्ट पॉइंट, सेकंड पॉइंट, थर्ड पॉइंट, फोर्थ पॉइंट। एक्चुअली बीम इज वन। हेलो, बीम इज व्हाट? वन। मैं क्या करता हूँ, यहाँ से बीम लेता हूँ, फ्रेम, क्लोज इट, दिस इज द फर्स्ट पॉइंट, trying to click over this point, right? Hello.
यस
Yes, sir. Yes, sir.
But this option, what problem I need to face? यहाँ पर मुझको लोड असाइन करना है, इट इज व्हाट द पॉइंट लोड। और पॉइंट लोड आप लोगों को पता है ज्वाइंट के ऊपर हम लोग अप्लाई करते हैं। हेलो,
यस
Yes, sir.
मैं ETABS पे आऊंगा तो यहाँ पर ज्वाइंट में सिलेक्ट कर सकता हूँ। सी आई एम ट्राइंग,
नहीं
या एंड पर है ज्वाइंट, यहाँ पर भी है, बट हियर इट इज नॉट पॉसिबल।
Point assign करना.
सॉरी,
Joint define करना होगा उसको वो point पे.
ज्वाइंट डिफाइन करना पड़ता है। ओके, वेरी गुड। तो इसके लिए क्या करना पड़ेगा? हम लोग अंडू करते हैं स्टेप को। टेक द फ्रेम, मैं क्या करूंगा, बीम इस तरीके से लूंगा। आई विल टेक द बीम लाइक दिस। सॉफ्टवेयर विल ट्रीट इट एज अ वन बीम, नो नीड टू वरी अबाउट। हेलो,
Yes, sir. Understood.
Okay, sir.
तो अब ज्वाइंट में सिलेक्ट कर सकता हूँ, राइट? नाउ गो टू दिस सिलेक्ट ज्वाइंट। First, we will assign the support. Clear this. Left is fixed. Select this joint. Go to assign. Go to join. Go to restrain. Make it as a fixed. Let's say apply. This is done. Fixed support has been assigned. Now, after that, here the loading is 300, 500, 800. So 300 Newton. How much it will become?
0.3
3 kilonewton.
0.3, 0.5, 0.8. Drag it from left to right, select the joint, go to assign, go to joint load, go to forces, and under the live load pattern, how much intensity?
0.3
Sorry?
0.3, sir. 0.3.
3. अभी देखिए एक और चीज, one more important thing. If I am going to click over this OK button,
minus 0.3.
minus 0.3. If I am going to press OK, so what will happen? The assignment will be done, but your dialog box will be off. Actually, I have to use that dialog box again, but it is what removed. Then I need to go to select the joint, then go to assign for all the beginners. Okay, after a long time, you will come to know all these things. So go to assign, go to joint load, go to force. Now it is available here. Now how much loading is there? 0.5. Joint is selected. If I am going to select, click over this apply, assignment will be there, plus your window will not off. Hello?
Yes,
Right?
sir.
Yes, sir. Yes, sir.
This thing you have to remember, very basic. Drag it from left to right, joint is there. Assign the load as 0.8. Let's say simply apply over this. Is that all clear or not?
Yes.
Yes, sir.
Yes, sir.
Your assignment is
Yes.
done. Now close it. After that, mute your mic. Everything is now has been done. Now I need to go to analyze, check your model once. Let's say apply or click over this. Check your model. Is there any modeling error or not? This is done. Now perform the analysis. Okay, now analysis has been done, and animated start animation. Okay, right animation is there. Stop. Thereafter, go to display. First, I would like to see the shear force. So go to display, go to force stress diagram, go to frame pier spindle, and here axial force. So will it be possible in your member axial force?
No.
No. Then shear, I would like to see shear. Shear 2 2, shear 3 3. In which axis you have to look for the shear?
Shear to
Measure
Sorry?
Here to do.
Very good.
Shear to 2. Shear to.
Very good. Shear to 2. Say apply. Now it is the shear value you are having. Make sure that the values are correct. Negative value, okay. 1.6. Come back to your see. Shear force 1.6. Hello. 1600 Newton. Right or wrong?
Right.
It
Right,
is what? Minus 300. 1600 minus 300. How much it will become?
1300.
1300.
Come to this. Right or wrong?
Right.
Right.
Right,
Which
sir.
side?
800. Correct.
800.
800.
This what? 1300 minus 500 is 800. Right. Next. I want to see movement. Which axis I need to look at?
3 3.
3 3. Check this
3
movement. Apply. It is what? Movement. Negative movement is there. Okay. On the left hand side, minus 2.3. Means 2350 kilonewton meter. 2350 kilonewton. Sorry, Newton meter. Hello.
Yes, sir.
Yes,
Here
sir.
it is what? 1.55.
1.55.
1550. Here it is what? 640. Right?
Right.
Hello.
Yes, sir.
Yes, sir.
Yes, sir. Hello.
Yes, sir.
Okay. So this is the case. How to see what? Okay. If you would like to see the values also, check this. Let's say apply. So value will also showing color if you want to off this. Okay. One more thing I would like to show you here. Very interesting. Red color means your negative movement. Red color means your hogging movement. Hello.
Yes, sir.
Some when you will look at the plan, so plan if suppose simply supported beam is there or fixed support beam is there, so the bending moment diagram will be like this. So here red color you will get, here you will get yellow color, here you will get yellow color, here you will get the red color. So red color means what?
Okay.
Hogging movement, negative movement. Red color
Hogging
means
movement.
what? Hogging movement, negative movement. Or yellow color means what?
Sagging.
Sagging movement.
Positive.
Positive.
Remember, axial forces में क्या था? Red color means
Compression.
Compression.
compression, and yellow color means
Tension.
tension. Okay.
Shear force का बता दीजिएगा.
Shear force का ऐसा कुछ नहीं है. Okay. Hello.
Yes sir. इसमें नेगेटिव इसमें वो रेड आ रहा था.
Sorry?
शेयर फोर्स रेड कलर का आ रहा था.
हाँ, shear force को वही कह रहा हूँ मैं. Shear force का ऐसा आपको कोई वो नहीं है. That is what the consideration of
चलो माइनर एक्सिस का भी रिजल्ट दिखा दो सर.
माइनर एक्सिस का देख सकते हैं ना हम लोग. शेयर एज माइनर. माइनर में मैंने आपको पहले ही कहा वैल्यू आता ही नहीं है, बहुत माइनर रहता है. ठीक है. हेलो.
माइनर भी 0 है.
Axial force apply. Axial force is also 0. Everything is 0. Understood? Hello.
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Yeah. Now go to this. Clear this all. Close this and close it. After that, what point we missed to cover? Yeah. Okay. What next? After this, okay. Problem is what? Go to display. Go to force diagram. Go to frame pair and movement about 3. Problem. Some problem is there that I would like to share. Apply. Okay. If you want to know more detail about these stresses, shear force, bending moment, so right click over this element. Right click over this element. Once you right click over this element, so new dialog box will open, will give you all the information about this analysis result for this particular element. So ये member का देखिए आपका लेफ्ट में उतना ही shear force है, राइट में भी सिर्फ इतने पार्ट का डिस्कशन है. फॉर दिस पार्ट, फॉर ओनली दिस पार्ट देयर इज अ डिस्कशन. हेलो.
Yes, sir.
On the left hand side for this member, for on the left hand side moment is what? 2350, 2.350 kilonewton. If you are going to convert in Newton meter, so 2350. Okay. Right hand side 1.15, 1.55 means 1550. Close it. Right click over this intermediate one. Left 1300, right 1300. Shear force is uniform. On left 1.55, right 640. Okay, this is the deflection. At the mid part there is a more deflection, at the end there is a less deflection. That is what? How much the span of this beam? 0.7 meter. Okay, this is the scroll value. At what point you want to see the stresses? कहां पर आपको स्ट्रेस देखना है, आप देख सकते हो. For 0.7, 0 to 0.7, I would like to see directly what is the exact value at 0.22179. Say enter. It is the point. Exact value you can find for that. Will you able to do it manually in manual calculation?
No.
Hello. Tell me. Hello.
It is a very difficult task.
Time consuming.
Manually it's very difficult. If I am giving the beam, simply supported beam, if I am giving and asking to find out the stresses for this beam, तो आप क्या करेंगे, यहाँ पर मूवमेंट निकाल सकते हो, यहाँ पर मूवमेंट निकाल सकते हो, सेंटर पर मूवमेंट निकाल सकते हो. If I am asking, I need to have the deflection at this at every 0.01 mm interval distance. Will it be easy for you?
No.
How much shear is there, how much movement is there, how much deflection is there? Will it be possible?
No, sir.
But that is possible here in the software. Understood or not?
Yes, sir.
Okay, so that is the
Yes, sir.
thing. Okay, now close it. But that is not the important thing. Important thing is what? Actually this beam is a single element, and we have modeled this all in 3 parts. So that, okay, right, it is no problem, but I feel it is not more correct. There is an option, we can model as a single element, but अगर single element करेंगे तो problem क्या आने वाला है? Hello.
Point पर loading नहीं दे पाएंगे.
Loading का assignment करना difficult होगा. Okay, so that is not the case. कर सकते हैं हम लोग. Go to unlock, close it. Okay. एंड अच्छा, अगर मैं आपको कहूं कि लोडिंग हम लोग अप्लाई कर सकते हैं, तो फिर हम लोग को 4 ग्रिड्स लेने की भी जरूरत नहीं है, स्टार्ट एंड एंड लेंगे.
हाँ ले सकते हैं, बट उसके
ठीक है
लिए
ना?
भी इंटरमीडिएट पॉइंट देने पड़ेंगे बाद में.
नहीं, ठीक है ना, मैं आपको सोल्यूशन देता हूँ. लोडिंग आप अप्लाई कर सकते हैं. अगर लोडिंग अब मैं आपको सोल्यूशन दे रहा हूँ, सो फिर 2 ग्रिड पर भी काम हो जाएगा.
हो जाएगा.
हो जाएगा ना? ओके, गो टू फाइल. ठीक है, go to file, go to new model, say no, go to this third option, say okay. 2 grids only in x direction, in y1 it will be x direction, make it as 1. Go to custom, go to modify, go to display grid. अच्छा, total spacing कितना है? I think 2 meter it is, right?
Right, sir.
Yes, sir. Yes.
0.7, 0.8,
Yes, sir.
1.5 and 0.5, 2. So put it as 2, and this is all done. Make it as 1000. Okay. Make it as 1, 1, 1, and grids. Okay. This is done. Close this 3D view. Go to elevation along the grid first. Say apply. Now go to frame, close it from this first point, directly going to this point, right? Right click to off the continuity, go to this option to off, completely off the command, drag it from left to right to select the join, go to assign, go to join, go to restrain, select the fixed support. Let's say apply. This is done. Now in the last case, what we are doing, we are trying to we are limiting to ourselves to assign the load to the joints only. लेकिन मैं क्या कर सकता हूँ, पॉइंट लोड फ्रेम के ऊपर भी लगा सकता हूँ. सॉफ्टवेयर ने हम लोगों को ऑप्शन दिया है, यू कैन असाइन द पॉइंट लोड टू द फ्रेम एलिमेंट. सो सेलेक्ट द फ्रेम, गो टू असाइन. जब आप असाइन में जाएंगे, व्हेन यू गो टू असाइन इन दिस फ्रेम लोड, नाउ प्रीवियसली वी आर असाइनिंग टू द जॉइंट. नाउ लुक एट द फ्रेम लोड. Frame is giving the option to assign to particular point. Right or wrong?
Right, sir.
Yes.
Just go to this point and now go to this live. Now try to understand these things. You want to assign the force, okay. It is gravitational direction. Gravitational direction will always be bottom to base, bottom to top or top to bottom. What it will be? Sorry? टॉप टू बॉटम ग्रेविटेशनल, ऊपर से नीचे आएगा आपका ग्रेविटी. सो इसका मीनिंग क्या है, यू डोंट नीड टू पुट अ माइनस साइन. हेलो, ओके, अब आपको माइनस साइन पुट करने की जरूरत नहीं है. सो ग्रेविटी इज देयर. रिप्लेस एग्जिस्टिंग, यू नो वेरी वेल व्हाट डज मीन बाय दीस थ्री ऑप्शंस. नाउ हियर टू ऑप्शंस आर देयर, रिलेटिव डिस्टेंस, एब्सोल्यूट डिस्टेंस. ओके, रिलेटिव डिस्टेंस मींस व्हाट, whatever the span is there, it is dividing into 4 parts, 0 to 0.25, then 25 to 0.75, then 1. It is very complicated to understand. So don't consider it. Come to this absolute distance. At what distance, what load you want to assign, that's it. Which one is the easiest?
Absolute distance.
Absolute distance. So here, this is the complete frame. So for the complete frame, at what distance, it is a one element. So left end is 0, right end is total length. Remember, right point is the total length, 2 meter. So at what distance you want to assign the load?
0.53 Newton.
0.5 from left. Okay. So at a distance of 0.5, how much intensity of the loading is there?
0.3 Newton.
See, unit kilonewton, 0.3. Okay, so just go to apply. Right? Hello.
Yes.
Yes, sir.
Again, now make it is 0. Make it is 0. Under the live load pattern, we have assigned this load. Remember, okay. Now 500 kilonewton at a distance of what?
1.2 meter.
1.3.
Sorry.
1.2 meter.
1.2. Select the frame at 1.2 meter. I want to assign 0.5 kilonewton. Is it needed to put minus sign?
No.
No, gravity is there. So I'm going to click over this apply. Now 0.5 kilonewton load has been assigned, but this is now removed. Why it is?
Replace an is
Distance.
Exactly. Replace an existing option is checked actually. So what option should be checked here?
Add to existing load.
Very good. Undo this step if you want to come back. So go to editor and say undo. So now you will come to last step. Now these option add to existing and let's say simply apply. Sorry, what's the problem? Element is not selected. Select the element, now say apply. Is that clear?
Yes, sir.
Now at what distance? 2 meter. How much intensity of the loading?
0.8.
At a distance of 2 meter, intensity is 0.8. Add to existing option is there. Let's say apply. This is done. Clear or not?
Yes, sir.
Okay.
Yes, sir.
Now this is the case. Now perform the analysis and okay, save this model. It is asking to save the model. Okay, once you complete the analysis, it will show the result. Go to display, go to force stress diagram, go to frame pair spindle. Under the live load pattern, all the load we have assigned. And first I would like to see the shear, say apply. Now it is showing what? Complete element. If I am going to right click over that, now the complete element in once it is showing. Hello.
Yes, sir.
Yes, sir.
Okay, so on the left hand side is showing what? 1.6 kilonewton and 2350. So now it is very difficult to find the exact point, 0.5. some time. Exact. So I can directly put what?
Distance.
0.5. So at 0.5 this, then at what 1.2 what value is there that I can see, and I directly at 2 meter what value is there at the end that I can see. Understood or not?
Yes, sir.
Yes.
Yes, sir.
So this is all about how to model the beams, how to assign the load, and then how to perform the analysis, then how to validate the results of the beam, shear force and bending moment, and what axis consideration is there, major axis, minor axis for moment and for shear. Hope that you all understood everything.